Good morning and welcome to the first virtual field day here at the Honeybee Lab. I'm Garrett Dodds. I specialize in queen rearing, bee breeding, and instrumental insemination. I've been working with and breeding VSH bees for the last 13 years, and I'm going to talk a little bit about the work that we've been doing with VSH. So, a brief history. Mid 1990s, John Harbaugh discovered that bees can hold some resistance to varroa mites. In the following years, he was able to enhance that trait, discovered that it was a form of hygiene. So he coined it varroa sensitive hygiene, or VSH for short. So what the bees do is they're able to detect a reproductive mite in a capped brood cell, uncap the cell, remove the pupae, disrupting the reproductive cycle of the mite, causing the mite not to have any offspring, and in turn causes the mite populations to eventually drop. And doing this research and this breeding for this one specific trait, he was able to get colonies that did not require any type of chemical treatment and would survive and maintain low mite levels. When we ended up showing that bees to other beekeepers, so commercial beekeepers, they looked at the colonies. They were like, it's okay. The colonies don't look that great. The brood's spotty. Okay, so you have mite resistance, but if they don't produce any honey or they're not strong enough to go into pollination, then they're not going to do me any good. So we started working and thinking about ways to improve the beekeeping traits in this bee to show beekeepers that it can be done. And what we came up with was in 2007, we took these high VSH bees, raised daughters off of them, and open mated them in commercial operations so that they mated to non-resistant stock. That was commercially viable stock. And we would follow these colonies for a year. After a year, we'd verify the queen, check population size, mite levels, all the traits that we were interested in with the bees, and we would select out the best. And we would do that year after year after year. For about 7 years, we did that. And the goal of doing this was to maintain the mite resistance while adding those productivity traits that beekeepers want in the bees. And we were able to do that, but the issue is we were outcrossing, and so it maintained the VSH, but at various levels. Some colonies did really well, some others not so well with the mite resistance. So we decided that we needed to tighten things up, make the bees a little more uniform. So in 2015, we converted it over from outcrossing in commercial operations to a closed population breeding system using instrumental insemination so that we could control the paternal and the maternal side of the matings. And the goal was to improve the resistance so it was more uniform across the stock and to also improve those productivity traits. Because these bees originally were selected in migratory pollination operations, Tom Glenn, who used to distribute VSH breeder queens, coined the term poll line for pollination line. This was also a proof of concept that we could use for commercial beekeepers, bee breeders, and say, look, if you want resistance, you can have it in your bees. This is how you do it. Let us show you. So what's going on in the future? Well, we still have plans for VSH experiments and testing for poll line in the foreseeable future. So we are going to continue to breed and run experiments on these bees. But we are also going to be looking at working on a Helo bee project, which I'll talk about in a little bit. First, I just want to show you what we were able to produce with the poll line. As you can see, we set up the exact same type of experiment where we compared a poll line bee with Italian bees in a commercial operation, followed them for a year. This is the results. Poll line bees maintain low mite levels where commercial bees had significantly higher mite levels. One thing that we were working on was the productivity traits. Well, honey production was about the same in Pauline and commercial bees, so that was good to see. So the Hilo Bee project, one thing that we have issues with at the lab is we can produce these mite-resistant bees, these highly productive bees, but we have no way of really getting them into the industry in a large enough quantities to make a difference. And so we wanted to find somewhere where we could have this mite resistance in a commercial style bee that could be delivered in commercial quantities to the industry through the sale of production queens. What better place to breed bees than in Hawaii, where you can raise queens all year long? Well, David Thomas from Hawaii Island Honey Company also has an operation here in Louisiana, saw the work we were doing and said, that's what we need. That's what I need. This is going to help the bee industry tremendously. I'm willing to help with this. And so with him, Arista Bee and Project APHIS M, we all partnered together to create this Hilo Bee project to fulfill these objectives that we had. And to get things started off, give it kind of a kickstart, we imported Pauline semen that had the high VSH traits along with productivity traits into Hawaii, where they inseminated the queens. You cannot import live bees or queens into Hawaii, so we had to use semen. They were able to enhance the VSH trait in the bees there in Hawaii. They were also able to take other commercial stock in Hawaii and cross it with the stock they were working with to provide a nice large genetic diversity with the VSH trait in order to select these highly productive colonies that we were wanting to produce. So as I said, we have limited resources to do this at the lab. Commercial beekeepers have a lot more resources because they deal with larger numbers. So David Thomas has 6,000 production colonies in Hawaii, and those can be used to various degrees within the breeding program. He also built a lab so that the inseminations can be done. The varroa mite checks can be done looking at the brood, the mite washes, any lab work that needs to be done for the breeding program can be done there. And even hired technicians to do the work that focus mainly on the breeding of the Hilo bee. You can see them down there in the corner. And besides that, he's also provided where we have over 200 newts available to start inseminated queens and over 400 full-size field colonies to test these queens at production levels for the breeding work, and those are specifically for the breeding program themselves. The other part of this project was to get these queens out in large numbers to make a difference. Well, David Thomas, being in Hawaii, he's on the Hilo side of the island, where the other queen producers are on the Kona side of the island. So he's the biggest commercial beekeeper on that side of the island. He's able to set up isolated mating areas. He has 3 currently, working on a 4th one. They have around 2,500 nukes in each one, with a 2-mile radius around each mating yard, with 200 to 300 drone-producing colonies, all headed with Hilo queens to provide the right drones to saturate the area so we get the correct matings that we want with these production queens. So as with everything, we have to test and analyze because we're scientists. And so what we did is we set up several test trials. So in Louisiana, North Dakota, South Dakota, where we took Hilo bees and Italian bees, commercial bees, and compared them side by side in commercial operations. And what we found was that the mite resistance is very good. We were able to keep that mite resistance and keep it at good levels. Productivity, on the other hand, not so much. And they're not bad. They're 28% less honey production, so there's room for improvement, which is the reason we did these trials. We need to know this information so we know where to work, what to work on. Something else that we found out with these queens were put in May. They were marked, so we would watch to make sure they were the correct queens. the following February for almond pollination. The queen colonies headed by Hilo queens had twice as many colonies that were of grade to go into almond pollination compared to the Italians. And so that's another highly valuable trait for commercial operators. And so now we're continuing. We want to cover a larger geographical area. So we got Bee Informed Partnership to run several of these trials across the United States with the beekeepers they work with. So we have the same basic trial going on in Washington, Oregon, California, Michigan, and North Dakota, where we're comparing Hilo bees and Italian bees. And the Bee Informed Partnership crew is collecting all that data for us. Here again, here's a graph, just like for the Hilo, or for the Pauline, showing you the Hilo bees. In August, as you see, the mite levels are considerably lower than the Italians. The beekeeper did treat the Italians so that he didn't lose as many bees over the winter. But as you can also see here, the honey production, not quite as good as the Pauline yet, but it's getting there, but something we need to work on. So what's next for the Hilo project? The future of it is similar to what we did with the Pauline, where we are going to tighten things up. We're going to create a closed population breeding system using instrumental insemination, where we can maintain that high mite resistance. We can increase the uniformity of the bee. And we also are going to work on increasing that honey production and increasing the number of colonies, the population size, so that more colonies are rentable for almond pollination in February, like the beekeepers need. Just a couple days ago, the website hilobees.com went live. There's a lot of information on this website with the history of the project, what's happening now, even information on when the bees may be available, if you can help, all types of information. So I suggest you check that out at hilobees.com. And with that, is there any questions?